Hi, I'm Brent. I'm going to talk about my Internet of Things IoT project, which should segue more deeply into blockchain and the web. A LoRa transmitter with a red light sends sensor data to the white ESP32 LoRa board, which then connects into a Wi-Fi network, which sends data over WebSockets and onto a Node.js server. The Node.js server echoes out the data to other devices like my iPhone, but also writes data to a SQL database. I started with the tutorial from the ESP8266 shop website and added a LoRa link and the writing data to the SQL database functionality. IoT projects are not secure, so I added a cryptographic authentication chip. This should help me identify the device by a public key and hopefully be a springboard into understanding and applying things from BlockChain, which is working towards secure communication. The public key alone does not verify an identity. Security has been attempted with key servers and through key exchange parties, but the advent of the blockchain provides a new way to think about the web of trust through decentralized public key infrastructure, or DPKI. DPKI provided by the ledgers can be tied to something called a decentralized identifier, or DID. DIDs can be resolved to a DID document, and public keys can be retrieved from the DID document. Ownership of identity moves to the agent instead of a federated or centralized identity provider. Here's the process for working with DIDs. A DID is a URI pointing to a DID document. The DID controller is authorized to make changes to the DID document. Minimally, a public key is associated with the DID controller. Public keys are encapsulated in a DID document along with other information. This DID document is recorded on a ledger or distributed store of some sort. A DID subject identifies the entity the subject is about. The DID controller and DID subject may be the same entity. A DID is created by a DID method. More information beyond the basic structure of a DID may be found by including a DID URL. A ledger allows for cryptographic trust, but verifiable credentials mentioned later allow for a verified authority to provide trust. There are quite a few applications of DIDs and related specifications beyond IoT. With Learning Machine, you can now have your diploma issued digitally and not worry about having to go back to the registrar's office to get it again when applying for a job. The adventures in self-sovereign identity talk mentioned earlier can also apply for a bank account without having to create a password. This is just a few of the many uses in the space. To enable more advanced use cases like diplomas and licenses, verifiable credentials are needed. The verifiable credential is generated, i.e. cryptographically signed, by the issuer making an assertion for the holder. Both the issuer and the holder are identified by their own DIDs in addition to the DID describing the schema of the verifiable credential. The verifiable credential holder generates a verifiable presentation for the verifier, i.e. some entity wanting to see it, in order to prove that they possess the credential. According to Marcus's DID auth presentation, the simplest verifiable credential might mean proving I am me, i.e. basic DID auth, adding educational credentials, licenses, and ID cards, etc. is more. In the case of IoT, I believe the flow would be as follows. The private key would be generated by the cryptographic coprocessor, and the corresponding public key would be used in a DID document that would be recorded on the ledger. Verifiable credentials could be built off of this DID. Here are some more resources. One might ask, don't blockchains suffer from scalability issues? In one initiative for a solution, Microsoft is collaborating on the Sidetree protocol with their ION network. German Reed talks about SSI enabled by these technologies at a high, non-technical level, and the Decentralized ID website gives a broad overview of the space. Also, one might consider brushing up on blockchains for context.